Oral dosage of drugs. So we have different types and different forms of oral dosages of medication. We have a tablet. And in tablets, we're going to round to the nearest hundreds because some tablets can be broken into halves or to parts. They're usually called scored, but just to be consistent in the class, if you are solving for tablets, you need to round to the nearest hundreds, which is 2 decimal places. However, when we're solving for capsules, you have to have a whole number as your end answer. And why is that? That's because we can't split a capsule in 2. So we need a whole number. So you need to round to a whole number if you didn't end up with 1 as your answer. Okay. My writing's not as great. So round to the whole number. Liquids. Liquids is usually measured in like milliliters. So ounces, teaspoons, or excuse me, fluid ounces, because ounce is weight, right? So fluid ounce would be the liquids. We're going to round to the nearest hundreds on this to be consistent, because we do have available most of the time is the equipment we use, like measuring cups, the little spoons for toddlers, the feeding syringes for infants, is usually rounded to the nearest hundreds. Every now and then you'll get one that's just to the tenths. So as long as you know how to round, you can always make those accommodations. So this here is just reminding you that a tablet that's called scored means that it can be divided. So whenever we're solving and using doses calculations, we got another method. We have dimensional analysis, which I've been teaching to y'all. But this one here says, let's take the 3-step approach, which you should always apply this whenever you're solving for application problems. The first one says we're going to convert to ensure that all measurements are in the same system and same size unit. If not, convert before proceeding. So we do have an example I wanted to pull up right quick, and so I'm going to skip slides to go back and forth. Here's my example. So first one says we're going to convert. So what we need to do is look at it. We have an order that says 100 milligrams. We have a supply, meaning that's what's available to us, at 50 milligrams per tablet. And we want to know how many tablets is going to be administered in one dosage, right? So we're going to always take our order, and I'm going to put it over 1 because I'm visual and I need that. Now this again is dimensional analysis. I'll show you this next method we're fixing to do. But since we're solving for tablets, it needs to go on top. All right. So if I put it on top, that means my mg's on top already because it's the order. It has to reduce. So that means this part here goes on bottom. And we got to be able to reduce. So this is what it's saying in step 1, convert. We got to make sure the units can reduce. What if this was grams? If that was grams, then that means we need an extra conversion here, right? That means we would have to convert these to because if not, grams and milligrams will not reduce. But we do know there's a relationship. We know that for every 1 gram, it equals 1,000 milligrams. I needed a better spacing between those. So guys, you gotta make sure you have 1 space between your number and your unit. All right, even when writing. So anyway, this is where we would say, oh, okay, we need to add a needed conversion in here in order to reduce to get what we need for step 1 to convert. Sometimes, like this problem here, it worked out great. The units were the same. We didn't need this needed conversion. So let's go back here. 2, we want to think about it. We want to think, does it sound reasonable? You know, what it's asking for, does it sound reasonable? Can we administer that amount? This should be our last question, to be honest with you. We should actually use this as step 3 instead of 2. However, it's actually wanting you to think about your setup first. Does your setup look reasonable? Does it make sense? It's also, again, a last question. If, say, it told us to take 10 tabs in one setting, right? In one dosage, we're going to take 10 tablets. Well, that's not a good recommendation. That's not safe. And according to all the textbooks for this class that I've read, it says that they do not recommend you take more than 3 tablets at a time or capsules at a time. It could be harmful to you. So as a nurse or a person that's going to administer medication to someone, a caregiver, you would want to give them less amounts to take. That doesn't mean the milligrams are less or the grams are less. It just means that they're only going to have to consume 3 instead of 10 of them. So that's why you sometimes see like 500 milligrams per tablet versus 250 milligrams per tablet. It depends on the situation on why, because it'd be better to take 2 500s than it would to take 4 250s. So that's just a good example. Okay, so step 3 here says, let's use our step calculation. We're going to apply the formula method. So I'm going to use this one here, and I'm going to apply the formula method. So it says that we're going to have the desired over have times quantity. And it's going to give me my amount that we're going to administer. So what is this? The desired I've been using as my order. And also, guys, your patient always goes on top. So if you're giving a patient's weight or a BSA or whatever it is that's about the patient, they always go on top as well. Okay. But back to this. That was a little side note. Write that down, guys. All right. But in this case here, I'm going to call it order. We have our order, and we've been putting order over 1, right? Order over 1. Oops, that's supposed to be an R. There we go. Times my Q divided by my half. And it's going to equal my amount. Well, in this case here, they just wrote it to where our halves go under the order and my quantity out to the side. Well, this works out great when we are solving and our units are reduced well with each other. In this case here, what I mean by reduced well with each other, our units in the order is the same as the unit in the supply. So let's go back here. It said that we had 100 milligrams in the order. And when I go divide that, I'm going to divide it by my half. And my half is the actual strength, right? Because this is a strength, right? 100 milligrams of strength. And it was actually 50 milligrams. And quantity actually means like my tablet, per capsule, per milliliter, right? So that'd be 1 tab here. I like using the approximation sign because sometimes when you round, they don't always come out pretty. And my milligrams reduced with my milligrams. And now I'm going to say 50 goes into 100 2 times. So they're going to take 2 tabs. This is using formula method, guys. But however, sometimes when we use the formula method, our units are not the same here, right? So if they're not the same, then we're going to need another needed conversion to reduce the units out. So be careful with that. So let's use a formula method. Again, use the 3-step approach. You think about it. First, you convert if needed and set it up. And we want to think about it. Does it sound right? And we use our formula method or dimensional analysis. You can use either one. Just be careful. So here's a perfect example. So I'm going to use this on this next one. So we have an order, and it's 0.75 grams by mouth 3 times a day. So I have, let me get my mouse going. Okay, so now I have a supply of 500 milligrams per tablet. Well, if you notice, this is grams and milligrams. So we're going to need a needed conversion. They say conversion is needed. I call it needed conversion. I'm going to abbreviate. Needed conversion. And what do I know the relationship between grams and milligrams? I know for every 1 gram is equivalent to every 1,000 milligrams. So every 1 gram, we get 1,000 milligrams. So this is needed in order for us to solve for this. So I'm going to take my 0.75 grams. And let's use formula method, okay? Because a lot of people like that method. Well, I know I'm going to have more than one thing going on. So if I want my half, I want to set it up as half to quantity. We could do that. Let's do it that way. All right, let's set it up as half to quantity. But we have to be careful, guys. So half to quantity. So my half is 500 milligrams. And my quantity is 1 tab. Well, I have to be careful because this is actually on top. We just don't write that 1 under there. But I'm going to do it for sakes of purposes of making sure that I got it correct when I go to multiply straight across and divide. And I look at it, and my grams here and milligrams do not reduce. So I need this needed conversion. And I'm going to set it up over here. Well, if we look at it, we see that grams is on top, so that means grams needs to go on bottom over here. Milligrams is on bottom, so that means it needs to go on top. So now I'm going to reduce. I see that this gram here reduces with this gram. This milligram reduces with this milligram. Tablets is on top. I got what I need. So now I got 0.75 times 1,000. That means since it's times 1,000 and it's 3 zeros here, we're going to go 1, 2, 3. We're going to move that decimal place to the right 3 all over. And this is tabs. Oops. Correct my writing. So now what we're going to do is we're going to reduce this. We're going to say 750 divided by 500 gives me 3 halves tab, but you are not going to put that down on the order. The patient's going to take 3 halves, or tell the patient to take 3 halves. You're actually going to write this in decimal form. And since it's a tablet, we're going to round to the nearest hundreds if possible. In this case, the hundreds is a 0, so we don't put it there. If it's a capsule, we would have rounded to the nearest whole number. But now we're going to think about it on this dosage. Is it safe? Yeah, we're only telling them to take 1.5 tabs, so it's safe. So that was using formula method. You could do it in parts, guys. You don't have to do it all in one long line like I did. You could have actually converted this here to milligrams first, and then you already have it as 700, right? Milligrams over 500 milligrams, then reduced amount. You could have done it in parts, that's fine. So it says here the maximum number of tablets or capsules for a single dose is usually 3. They usually do not like to go over. So when you rethink about it, is it safe? If it's not, what do we need to do? So the rest, this is all reading for you. So let's talk about this one. In this class here, I don't talk about grain, guys. I just don't talk about it because people get GR mixed up with gram. But as long as you know how to solve, you're going to be all right mathematically. Also in grain, they usually put the number behind it, and in this class, we're always putting the number in front because that's how the notation calls for. So if we're in this class, it's like I said, it's calling for to go behind on grain. So grain can be a little misunderstanding. More people actually misunderstand the unit than anything, so I just don't use it in this class. But if we did use it, I'm going to go ahead and solve this. And I look at it and I notice that this is in grain and this is in milligram, right? Our order is in grain, our supply is in milligram. So we're going to need it conversion. So that's saying we need to go find our sorry guys, let me spit it out, my dosage calculation sheet if you don't already have it printed out. If you don't, go to Module 3, Dosage Calculation Metric. It's the main conversion sheet. So once I get that open, we can check it out. And what do I have? So it says that 1 grain equals 60 milligrams. The parentheses are also another rounding. So we're going to stick with just the 60 milligrams. Now let's get back to our, here it says 1 grain is equal to 60 milligrams. So knowing this, we can actually do our needed conversion. So this is the part I was telling you guys you could have done first. So I'm going to do it first. I'm going to do 3/4. Now, if you want to go ahead and put it in decimal form, that is fine. Right? So you could do it in dimensional analysis, or we can do it in formula method. Let's do formula method. So 3/4 grain over, what do we have? We have 30 milligrams per tablet, but we're solving for grains to milligrams. So I know for every 1 grain is 60 milligrams. Okay, so now I can go grain reduced with grain, leaves me milligrams on top. That's good. Then we got 3/4 times the 60. Basically means it's 3 times 60 divided by 4, right? So we know that 3 times 60 is 180. We're going to divide that by 4. Guys, if you ever do this part, don't round, okay? You don't want to round until the final answer because it can change everything. So now we know that this is 45 milligrams. We know that 3/4 grain is equivalent to 45 milligrams. Now it's in the unit we want. So we can come over and set up our next formula. And we're going to take this 30, right? Because it's my half. It goes in the denominator. We're going to multiply it by the 1 tab. And let's mark out the milligram and milligram. So now what do we have? We have 45 divided by 30, which is going to give me a fraction of 3/2. Again, we can't leave it in fraction form, so we have to write in decimal. And decimal is 1.5 tab. So I did have to go look up the conversion for this, and it's okay because we don't use this for you to go check yourself. And know that wherever you go, whatever class you go to, they may have a different rounding procedure. Of course, now the rounding, the main conversion sheet and this textbook, I have stuck with the program's rounding and the textbook's rounding. So if you use any other source for conversions, then your answer is going to be incorrect. And what I mean by rounding is if we was to get really technical about it, these numbers will not be exactly whole numbers. They'd be decimals. And that's why you saw where it said it could have been 64 milligrams to 1 grain or 65. It's because each place determined a safe rounding. So just as long as you can do the math and you understand the language, you can adjust to whatever rounding of whatever place you go to. And again, we just converted and we thought about it. So this is another example you can work on your own. Tip, Q is 1 tablet or capsule or 1 milliliter when we get to that part. H is going to be what's on hand, what's applied to us. It's usually a unit that we reduce with the other one. I call it the strength. Our desired is our order or our patient, or the recommendation to go on top. Thank you.